In the last section, we had to do a few problems with systems of 3 equations and 3 variables using the Gaussian elimination method. And as you saw, that method took forever. So this new technique that we're going to show in this section relies on knowing what a matrix is. Will just be done on a calculator. So all you have to do on paper is record the numbers and then put them into your calculator, hit a couple buttons, and then you're basically finished. The problem that took 15 minutes in the last section will take like roughly 30 seconds in this section, if you know what to do. So we're talking about matrices now. What are matrices? A matrix is just a rectangular array of numbers. Basically, it's just a list of numbers. The numbers inside of the matrix are called elements. So like, for example, this right here is a matrix, 2 is an element, 7 is an element, and so on and so forth. Now, matrices can be used to represent systems of linear equations, and they could be used for other reasons in other fields of mathematics. But for now, these matrices just represent numbers. And then we normally write a little line like this where the equal sign would have been. So how do you come up with this matrix? How do you write it? What's important is you lining up the letters and the equals and the numbers first. Make sure everything is lined up first. Once you make sure everything is lined up, you just grab the numbers only. So you grab the numbers and you write them down with a little space in between. And then you go to the second equation, the number is 1, 4, and -2. And then you put them right there into the second line. And basically you're finished. That's it. Now, where was the equal? The equal was before 7 and -2, so that's the reason why you put the little line. And that matrix that we just wrote has 2 parts. It has a part that is called the coefficient part. So these are the numbers that were in front of the letters x, y, and z in the earlier problem. So they're called the coefficient matrix. And there's the other side of the matrix that we don't really care for. It's just the answers that you had after the equal sign. Those, are kind of irrelevant for now. They don't have a name. Okay? So far so good? Well, let's see. Now, each one of these is going to be called a row. That's the reason why you heard me use that word previously. Each one of those things are called rows, and each one of those things, 2, 1, 3, 4, 7, 2, each one of those are called columns. So this matrix that is written over here on this paper has 2 rows and 3 columns. This is the reason why we call it a 2 by 3. So when I say the words 2 by 3, you're going to hear 2 first. So you're going to say this matrix has 2 rows, meaning 2 equations, and 3 columns. What does it mean to have 3 columns? It means that we have a letter X, a letter Y, and then a numbers column. That's what this means. And that is important because the very first thing the calculator wants from you is the size of the matrix. So what is it? Is it a 2 by 3? Is it a 5 by 7? So that the calculator can get into that mode that can solve the problem for you. This whole thing is called an augmented matrix. The word augmented just means that your matrix has the coefficients and the numbers after the equal all written down. If I write just the coefficients, then I will call it the coefficient matrix. Together, coefficients and equals are going to be called augmented matrix. So let's start by seeing if we can write some problems as a matrix. So again, the way that you want the system is, first of all, you want the numbers to be all organized before you turn it into a system, before you turn it into a matrix or whatever. So the first equation right now is all messed up. We need the 2x first, we need the 5y after, and we need the -4 all the way at the end. The second equation is all messed up. We need the x to be first, so I'm going to move it across to get it first. Then I need the y, which is already there. Then I have to have the equal sign, and I need the 2 after the equal. Okay, so this is the system. And now let's write the augmented matrix. So what is the augmented matrix in this problem? And what is the size of this matrix? So the augmented matrix itself is going to be 2, -5, -4, and then 4, 3, 2. we put the brace on the side, the brace on the other side. That means it's a matrix. And the equal used to be before -4 and 2, so we're going to write a little line right there. Now watch out, the calculator normally does not display the line. It doesn't have a way to do that, so you're just going to have to imagine the line there yourself. What's the order of this matrix, or what's the size? When we say size or order, we're talking about there are 2 rows, 1, 2, and there are 3 columns. So this is a 2 by 3. So that's what we call this matrix. It's a 2 by 3 augmented matrix. What's the coefficient matrix? The coefficient matrix is 2, -5, 4, and 3. Together with the 4 and the 2 on the other side, it's called the augmented matrix. Now, if your 2 by 3 were ever the same number, then that's known as a square matrix. If your 2 numbers are the same for rows and columns, we call that a square matrix. That's special in later classes. Okay, so let's take a look at the second problem and see if we can organize it and write the augmented matrix. So the first equation is all messed up. We need the letter x first, then we need to have the y, so I'm going to move it from the left to the right, and then I already have the z there, and it's all equal to -4. Great. The second equation should have the 3x first, so I'm going to move it first. The y is there already, so it's good, the -2z, and it's equal to, there's no numbers, so I'm going to put 0 there. And then finally, the 4x is already good. The 2y needs to be in the middle, so I'm going to put the 2y in the middle, and then finally the 3z, and it's equal to 6. So this is my system in the original form. What I need now is the coefficients and the numbers. So I'm going to turn it into a matrix. So this is my augmented matrix. 2, -5. The z has no number, but we will write down 1 for the z, and then -4. And again, -3 for the x, and then again 1 for the y, because there's no number there, and then -2, and then 0. Finally 4, -2, 3, and 6. Please, whatever you do, make sure that you space out these numbers. Don't squeeze them to -5, 1, because then I can't tell if you're adding or subtracting the numbers anymore. And it's going to get screwed up when you try to put it in your calculator. So try to space out the numbers and be as organized as possible in this section. So now that we have this matrix, what is the size of the matrix? So remember, the size is the number of rows multiplied by the number of columns. So there are 1, 2, 3 rows. So this is a 3 by 1, 2, 3, 4 columns. So it's a 3 by 4 matrix. And we need to put that into the calculator first before we can actually get answers from the calculator.